Okay, so Leetcode practice time. So in this video there are two goals. The first goal is to see how to solve this problem, and then we are going to do some coding work. And the second one is to see how you should behave during a real interview. So let's get started. In the real interview, the first step is always try to understand the question, ask some clarification questions in case you have anything unclear, and at the same time think about some edge cases at the very beginning to see what you should do, especially in the next step. So let's take a look. Find k closest elements. So given a sorted integer array, two integers k and x, return the k closest integers to x in the array. So the result should also be sorted in the order. Alright, so let's see. So an integer a is closer to x than an integer b if the absolute value of a minus x is smaller than the absolute value of b minus x, or if they are equal and a smaller than b. So integer is closer to b. Okay, so if the absolute value, the absolute difference is the same, then we choose the smaller one. Okay. So let's see example. So for example 1, we have ARR as 1, 2, 3, 4, 5, k as equal to 4x equal to 3. Then we have 1, 2, 3, 4. I see. So the reason it's not 2, 3, 4, 5 is because we choose the smaller thing over the larger thing. Okay. So let's see some constraints. So the k is between 1 to the length of the array, which means the input array is never going to be empty. So we don't need to think about that edge case. Okay, and the array is always in ascending order sorted. So the array, the number within the array and x could be between minus 10k to 10k. Alright, so I think I pretty much understand the problem. I don't really think there's some special edge case we need to really think about. So let's step into the next part. Let's find a solution. So how to solve this problem? So I would say we need to see. So because this array is sorted in ascending order, so if the x we are looking for is smaller than the smallest element within the array, we just get the first k elements. Otherwise, if it is larger than the largest element within the array, then we are going to return the last k elements. So if x is in the middle, then we need to call binary search. We need to use binary search to find the corresponding number within the array. So if the binary search, if x doesn't within the array, we just return the closest number to x. So it's like, first of all, we do binary search for array within x, and it is going to return a index, and then we are going to use this index to try to find the k closest element. So what are we going to do? So we are going to search within the range of index minus k to index plus k. So within this range, we can find the k closest number. And how are we going to find the k closest numbers? So we are going to use a two-pointer approach. So let's say I am trying to find 1, 2, 3, 4, 5, 6, 7. So let's say we have those numbers, and we are trying to find the 4 closest numbers comparing to 4. So we are trying to let's just say we are going to find 3 closest numbers to 4. So at the very beginning, we do binary search and we find the index. So this is the index pointing to 4, and we try to extend on the left side. We try to extend 3. So this one is starting from here. This is the left pointer, and similarly we have the right pointer. So this is the right pointer. So how are we going to choose how are we going to move the left pointer and right pointer? So first of all, we compare the absolute diff with the with 4. If the absolute difference of the left number, the number pointed by the left pointer, if that one is smaller, then we try to move the right pointer. Otherwise, we try to move the left pointer. But if the absolute difference is the same, then we are going to move our right pointer towards the left side. So in this case, the diff is the same, so we are just going to move our right pointer to the left by 1. And similarly, just follow the procedure I talked about before. So if the absolute diff, we try to move the pointer with larger absolute diff. So this time the left pointer has larger absolute diff, so we are going to move the left pointer to the right by 1. So the condition we stop moving the left and right pointer is the number within the left and right pointer is equal to k. So that's the condition we stop moving the pointers. And then the numbers within the left and right pointer would be the numbers we are going to return finally. So having said that, this is about the general approach. The runtime is going to be log n. So binary search is going to be, so n is the number of is how many numbers within the input array. So log n for the binary search, and then we are going to do kind of like a scan 2 numbers. So I would say it is log n plus k. So it is O log n plus k. So that's the total runtime. So let's do some coding work. After you're done communicating with your interviewer about the approach and you get an agreement, do certain runtime analysis, space analysis, then it's time for you to do some coding work. So for coding, we care about the speed, correctness, and the readability. So let's give it a shot. So as I said, if ARR is 0, so if x is smaller than or equal to the smallest elements, then we are just going to return so we are going to get the first elements. Let's define a helper function. So this one, it is going to return a list of the integers. Let's say get subarray. So we are going to pass in the array start index and the end index. So list of the integer, let's say new, let's say linked list. I is equal to 0. Sorry, smart start. I is smaller than n. Plus I. So dot add ARI. And then finally we are going to return RT. Alright, so here we are going to call the subarray. Return subarray of AR from 0 to k minus 1. Otherwise, if alright, so it's not otherwise, if x is larger or equal to ARR, okay, it's ARR.length minus 1. So if it is larger than the largest one, then you're going to return get sub ARR. This is ARR. Then the last one is ARR.length minus 1. So what is the start index? So this would be AR.length minus k. Alright, so yeah, so that's the two different cases. Otherwise, x is within the smallest and the largest. So first of all, we are going to call we are going to do binary search. So I think there is binary search API. I think it's collections, binary search, whatever. Binary search, okay, Java 8. It's alright. So okay, binary search. So this is a binary search API already implemented. So let's see what it is going to return to us. Here. So it is going to search the specific list for the specific object. It's sorted in natural order, and what is going to return? So the index of the search key if it is contains in the list. Otherwise, we are going to return minus the insertion point minus 1. So insertion point is defined as a point at which the key would be inserted into the list. Okay, I see. So we are going to call the binary search collections dot binary search on top of this AR. So it is list. I'm not sure. So it says it's not applied on top of. It's only applied on top of the list instead of array. So how? Okay, so for geek binary search. Alright, so it only applies to binary search Java 8, let's say array. Is there any binary search on top of it? So yes, so we do have some binary search. It's called arrays.binary search for a key. So let's see this. So if we call binary search, it is going, okay, so it's the same. So we are going to call arrays.binary search the array for the corresponding number. So if the index is smaller than 0, that means it doesn't exist. Then it means it doesn't exist in the input array. So we are going to change it to be this would be, so it is going to return minus insertion point to be minus 1. So you're just going to be minus index plus 1, I think. Yeah, so it actually could just have it like this. The insertion point is defined as a point at which the key would be inserted into the array. So the index of the first element in the range greater than the key. Okay. So it is minus. Okay, minus the insertion point minus 1. So it could be minus. Okay. Okay. minus, if I minus the index, it is going to be minus x is going to be positive in the insertion point, positive 1. So actually it should be minus 1 minus 0 minus, yeah, it should be like this, minus 1 minus index. Alright, so we have the index of the insertion point or the index of the corresponding number, so we are going to try to extend it. So first of all, the left pointer would be mass dot max 0, and also this is index minus k. Yes. So if it is minus k, how many numbers are there? So index to index minus k, there are actually k plus 1 numbers. Okay, I think it's just fine. So mass dot min equal to index plus, this one should be min, in between the index plus k to array dot length minus 1. Alright, so we're going to and also let's define the final thing we are going to no, so we don't need to define it here. So we are going to move our left and right pointers. So well, the right minus left plus 1 is larger than k. Why it is larger than k, what we are going to do is we are going to move the stuff. So if alright, so I would say int abs_l is equal to mass dot abs, this is array left minus x, and let's see, abs right, it is going to be right minus this one. Alright, so if abs_l is larger than abs, so if it is this one, so if it's abs_l is smaller than abs_r, then we are going to try to minus the right. If it is equal, then we are also going to minus right. Otherwise, we are going to plus the left. And finally, we just need to return get sub ARR, ARR and the left and the right. So that's pretty much about the code. After we are done with coding, it's time for us to do some certain testing. So for testing, we care, first of all, it's about sanity check. Goes through a simple example, checking the logic and explain how this piece of code is going to work. And also, you're going to increase the test coverage by introducing different test cases after that. So let's see. Let's take an example. Example 1. I have 1, 2, 3, 4, 5, and k as 4, x as 3. So at the very beginning, we compare with the smallest one and the largest one. So none of them are true. So we are going to get into this part. So binary search is going to return index as 2. So left and the right. So left would be 2 minus 4. Max between 0 and minus 2. So it is going, left is going to be 0, and similarly right is going to be 0 as well. So we are going to try to move left and right pointer. So we see, alright, so the absolute value between 1 and 3 is 2, absolute value between 3 and 5 is 2, but although it's the same, we are going to choose to move the right pointer because of this if branch. So we move. So left pointer is here, right pointer is here, left pointer is here, and then we see that the right minus left plus 1 is already equal to k, so we just break this while loop. So, and finally we are just going to return the 4 numbers. I think we are mostly good. Let's give it a shot. Okay, so it's good. Let's do a submission. Alright, so it seems like everything is good. So I would say regarding the task case setup, definitely set up something that is going to touch this if branch, and set up another task case that is going to touch this if branch, and also set up a task case like example 1, which the input array contains the number x, and also I would say another task case. Let's say if the input is 1, 2, 3, 5, 6, so you're going to search like 4, which doesn't exist in the array. So I would say that's pretty much about all the test cases I can think of that can give us good enough test coverage. So that's it for this coding question. If you have any question about this puzzle or about the solution or whatever, feel free to leave some comments below, and thanks for your time watching. I'll see you next time. Please subscribe to this channel. Have a good night. Bye.